Hello everyone. In this video, we look at the vertical straight line motion, second part of the discussion. Already in the first part video, right, we have talked about what are the aspects that we have to consider in the vertical straight line motion, and we have seen one case of the vertical straight line motion. So, which is if you throw an object from the surface of the earth, it will go up and then it will again return back. So, that particular case we have seen in the part 1 video. In part 2 video, we look at the other 3 cases. Totally, we talked about the 4 scenarios in the vertical straight line motion. We look at the other 3 cases and also we'll try to solve some numericals based on that. Okay. So we will start with the second case. Second case is from a height, whether the person is standing on top of building or some cliff or any. So from a particular height, if you are dropping an object. So dropping means already we talked about it in the first part of the video. So here we are considering that the person who is dropping this object is stationary. Means the initial velocity of that body which is being dropped will be what? 0. Now what is going to happen? The object is going to keep coming down. So when it finally comes down, reaching the surface of the earth, right, it will have some velocity. So initial velocity is 0, but it will pick up velocity because it will have an acceleration of g downwards. Now in this motion, right, there will be 2 things that we will be interested to find. One is the time it takes to come down, and what is the final velocity. So when it reaches the surface of the earth, what will be the final velocity. So first we will start with the information that we have. So we know that initial velocity will be what? Because we are dropping or releasing, initial velocity will be 0. And acceleration, as per our sign convention, down is negative, up is positive. So when it is finally coming down to the surface, it is actually coming down by h. Means the displacement, right here, displacement will be what? Negative. Why it will be negative? Because from the top of the building we are coming down, right? So direction of the displacement is what? Downward. So we will have to take the displacement as what? Minus h. So we want to find the time of the journey. Means what is the equation? Initial velocity, acceleration, displacement, time. What is the equation we have? S is equal to ut plus half at square. Means displacement is minus h is equal to what? U into t. Initial velocity is 0 plus half into acceleration is minus g. So this is anyway 0. So minus h is equal to minus gt square by 2. Minus minus is cancelled. 2h by g is equal to t square. So from here we will have t is equal to what? Root of 2h by g. So this is the time it takes for the object to actually come down to the surface. Okay, so this is an important result. If you remember in the result, means it will actually come to our help when we are solving some problems. So if you are dropping an object from a height h, the time it takes to come down will be what? Root of 2h by g. Okay, so if you know that, okay, you are dropping an object from a building of height 40 meters, then straight away we can use which formula? Root of 2 into 40 divided by g. G, if they ask us to take it as 10 meter per second square, we will take it. Otherwise we have to take it as what? 9.8. Okay, so this is about the time it takes to come down. Then we will also try to find out, same for the same scenario, we will also try to find out what will be the final velocity. So here initial velocity is 0, acceleration minus g, because it is going to be downwards. Always in our sign convention, up is positive, down is negative in the vertical straight line motion. Okay, so when it is coming down, the displacement will be equal to what? Minus h. Why are you putting minus h? Because it is coming down by h, right? So displacement is downward direction, that is why negative. Okay, and we are looking for what is the final velocity. Let us say this is v. We have to find this value. Initial velocity, acceleration, displacement, final velocity. What is the equation we have? V square is equal to u square plus 2as, right? So final velocity square is equal to what? U square. Initial velocity is 0 plus 2 into acceleration is what? Minus g into displacement is minus h. So we will see v square is equal to minus minus will multiply by, will become plus. V square is equal to what? 2gh. From here we will say v is equal to what? Plus or minus root 2gh. But if you look at it, right, our final velocity will be downwards. So as per the sign convention, we will take it as what? Root 2gh minus because downward will be what for us? Sign convention wise, it will be what? Negative. But if we are just looking at the magnitude, right? What is the magnitude of the final velocity? It will be root of 2gh. If an object is dropped from a building of height h, then the final velocity it will have when it is reaching the surface will be what? Final velocity magnitude is what? Root 2gh. But direction wise it will be what? Downwards. So this is about the case 2, where we are dropping the object from a particular height. We look at a question. A ball is dropped from the top of a building. What is the ratio of the distance covered in first second to the second second of journey? Here they are not even giving us, so we are dropping the object from that building. Okay, so this is the building. They are not even giving what is the building height. Okay, which means what? In this problem we might not require it. So we are dropping, right? So initial velocity is equal to what? 0. And acceleration, they are asking us to take it as what? G value, they are asking us to take it as 10 meter per second square. Our sign convention wise, downward will be what? Acceleration is downwards, right? So it will be what? Negative. What are we supposed to find? The ratio of the distance covered in the first second to the second second. Remember, we have these displacement in the nth second formula, SN formula, correct? So for that formula, right, we need to keep in mind that this is giving us the displacement. But since the object is going to keep going down, it is not going to change its direction of motion. It is going to keep going down, right? So the displacement magnitude will be equal to what? Distance covered. So first we will get what is the S1. S1 is what? Displacement in the first second. What is the formula? SN formula is what? U plus A by 2 into 2n minus 1. That is the formula, right? U is 0. So A by 2 minus 10 by 2 into 2 into first second means n is 1. So what is it? 2 into 1 is 2. 2 minus 1 is 1. So totally it is what? Minus 5 meter. That is S1. Take a modulus means what is it? 5 meter. Here S2 will be what? U is 0. So minus 10 by 2. 2 into 2 minus 1. What is it? It will be minus 15 meter. So if we take a modulus means what is it? The displacement negative is telling us what? That the object is moving downwards. That is why the displacement is shown as a negative. Take a modulus means that will give us the distance covered. What is it? 15 meters. They are asking us what? The distance covered in the first second, which is modulus of S1 is to modulus of S2. What is it? 5 is to 15. That will be 1 is to 3. Okay, so that will be the answer for this question. In fact, this is a very standard question, because in some of the past years also we have got similar type. They can even ask what is the ratio of the distance covered in the third second to fifth second, like that. So always we have to use the SN formula that will give us the displacement. We have to take the modulus. Okay, so now we will move on to the next category, which is the category 3. What is the category 3? We are projecting a body vertically down from the height. So from that height we are not dropping it, we are basically throwing it down. It's like, we are throwing it down. So when you throw it down, the initial velocity will have some value. Initial velocity will be having some value. So what is going to happen? This object is going to come down and it will reach the surface of the earth. So here if we are throwing it down with a velocity u initially, right? Remember, as per the sign convention, we have to take the initial velocity to be what? Negative. Why? Because downwards means negative. What about the acceleration? Downwards means, because always the acceleration is g downwards, right? That is fixed. It will be what? Minus g. Then when it is coming down fully, what is the overall displacement? It has come down by h. Means the displacement will be what? Just like the case 2. When it is finally coming down, the overall displacement will be what? Minus h. The only difference between case 2 and case 3 is what? The case 2 doesn't have any initial velocity, case 3 is having initial velocity. Okay, that is pointed downwards. Now we want to find the time of the journey. Means what is the equation? Initial velocity, acceleration, displacement, time. What is the equation we have? S is equal to ut plus half at square, right? Means displacement minus h is equal to initial velocity into t plus half into minus g into t square. We can see both sides we have negative, we can cancel it off. So what you are going to get? H is equal to ut plus half gt square. So we are not going to solve it because this is a quadratic equation based on whatever the parameters, right? Like they say the building height is 80 meters. They'll say that initially it is thrown down with a velocity of 5 meter per second. So we are going to substitute all the values and we will get the solution. So in this generally we will get two values of time. One of them will happen to be negative, that we will not accept. We will only take the positive value of the time because time is the measurement that will be always positive. Okay, so that is the approach to find what is the time it takes to come down. That is one. And when it is finally coming down, right, it will have some velocity, the final velocity. So what is the final velocity? If you want to calculate the final velocity, let us say it is v. So we can relate initial velocity, acceleration, displacement and final velocity. What is the formula for that? I'll use a different marker so that we can see that. What is the formula? V square is equal to u square plus 2as, right? Means final velocity square is equal to initial velocity square, okay, plus 2 into acceleration is minus g into displacement is minus h. So v square is equal to what? Minus u, if u square means it will be u square only. Minus minus is cancelled. So v will be equal to what? Plus or minus root of u square plus 2gh. V will be equal to what? Plus or minus u square plus 2gh. In this, we know that it will be downward. So we'll have to take the negative value. But if you are just looking at the magnitude, means what is it? The magnitude will be what? Root of u square plus 2gh. The final velocity magnitude. Direction wise, it will be downwards. So by solving this quadratic equation, we will get the time it takes to come down. And the final velocity value, we already have it. What is the final velocity magnitude? Root of u square plus 2gh. So like I am saying, right, all these standard results, we have to keep them in mind so that they will be helping us a lot while solving questions. Now we'll go to the fourth and the last case. What is it? From that building of height h or the tower, we throw it up. So we throw it up with a velocity. So let us say the initial velocity is some value u. It may be 5 meter per second, 10 meter per second. It can have any value. Okay. So what is going to happen? This object is going to go up. And remember, in the part 1 also we talked about it. In this particular scenario, right, our understanding is that, okay, you are throwing it by standing on the verge of the building. So the object is going to go to that a maximum height point. After that, it will not come back and fall onto the terrace. It will be coming back and falling on the surface. It will come like this. So this is the total journey. In the fourth case, right, it is not like from the tower it will go up and fall back onto the tower. The assumption is what? It is like, we are standing on the edge of the tower and throwing. So the object will go up and then it will come and finally it will be coming to the surface. So this is the final position. The surface of Earth is the final position. Okay. Now in this entire journey, we will look at the parameters. What will be the parameters? Initial velocity, because we are giving it upwards. So we have to take it as what? Plus u. Acceleration minus g. Always g downwards, we will take it as negative. Downwards is negative, upwards is positive. Now for the entire journey, right, if you want to look at what is the displacement, entire journey means what you know. So from here, you are going up and then coming down to the surface. Observe one thing. If I ask you what is the displacement, what you will say? Displacement is what? Displacement is different from the distance covered. So going up and coming down is what? This is giving the total distance covered. So if you look at it, right, what is this total length? If you measure the total length, means it is going to give us what? The distance covered. But here we are not looking for the distance. S is what? Displacement, right? What will be the displacement? This is where you have the initial point. Correct. And where is our final point? This is our final point. What is the displacement? From initial point to final point, shortest distance, right? So displacement of the overall journey will be what? Initial point is above, final point is below. So displacement is downward direction. How much is the value? Whatever is the height of the building. But since it is downwards, we have to take it as what? Convention wise, negative. So the overall journey displacement is going to be what? Minus h. So this is an area where lot of us will have confusion. So why are we taking the displacement as minus h? We have to be clear. Why? Because it is going up, yes, and then coming down. So distance covered means we have to look at the total length of the path. But in our equations of motion, we are not at all using the distance. S represents what? Displacement. Okay. Now here also we can find what is the time of the journey. Let us say t is the time of the journey. Journey means what here? Total journey. So initial velocity is given, acceleration is there, displacement is there. Can we find the time? What is the equation? S is equal to ut plus half into a t square. Okay, so if you look at it again, what we'll have a quadratic. Maybe if you want, you can just multiply both sides by minus. What we'll have, h is equal to half gt square minus ut, like that will come. If you multiply both sides with minus, check it. So multiply both sides with minus means what? A minus h will become plus h, minus half gt square will become plus half gt square, but ut will become minus ut. Okay, so this is what a quadratic equation. By solving this, we are going to get two values of time. Two roots will come. One of them will happen to be negative, other one which is positive, we'll accept it. So here also I am not solving the equation. Why? Because depending upon whatever is the parameters given to us, right, what is the h value, what is the u value, we will be able to, when we go to the respective problem, we can see that, and then we will be able to solve. Okay, so this is about the time it takes to come down. And the other aspect will be, when it is coming down, obviously it will have some velocity. So that is what we call as the final velocity. Let us say it is what v. So initial velocity is known, acceleration is there, displacement is there. We want to find the final velocity v. What is the relation? V square is equal to u square plus 2as. Means v square is equal to initial velocity square plus 2 into acceleration into displacement. So minus into minus will become what? Plus. Here also v is equal to what? Root of u square plus 2gh, plus or minus. But since we know that the final velocity is downwards, right, sign convention wise we will take it as what? Minus. But if we are just looking at the magnitude, what will be the magnitude? Root of u square plus 2gh. This is the magnitude of the final velocity. Okay, so this is how we look at the fourth case. What is the fourth case? Standing on top of a building, we are throwing the object up. So it is going to go up till it reaches that maximum height, and then it will fall down. Where it is going to fall down? Our assumption is we are throwing it from the edge of the building. So it is going to fall down not on the building top, but it will be falling back onto the surface of the earth. So that is representing the total journey. Okay, so this is about the fourth case. Now what we'll do is we'll look at some sample questions on this. A ballast bag is dropped from a balloon that is 300 meters above the ground. So we have the balloon which is already 300 meters above the ground. So this bag is basically what? This is the bag. The bag is basically dropped from the balloon which is 300 meters above the ground and rising at 30 meters per second. Means what? The balloon is rising at a 30 meters per second speed. See here, this is a case of dropping an object from a moving entity. The balloon is what? The balloon is moving, right? So the bag initial velocity will be equal to what? It will be equal to the velocity of the balloon. So the bag initial velocity is what? We will take it as plus 13. Why plus 13? Because it is going up. The time before the bag hits the ground. See, look at it. No, the bag is given a velocity of 30 meters per second initially. What is going to happen to the bag? The bag will, as soon as it is dropped from the balloon, right, the bag will go to a certain height and then it will start falling back. Where it will fall back? It will fall back to the surface of the earth. It will fall back to the ground. Okay, so this is like what? From the top of a building or from the top of a certain height, we will throw the object up. Same scenario, right? The difference is what? You are not, standing on top of a building or a tower and throwing it up, but instead the object is being dropped from the balloon. The balloon itself is moving up. So the bag, once it is released, it is having a vertically upward velocity. So it is same as standing on top of a building, throwing the object upwards. Okay, so we have to correlate both the cases. This is what? This is like the case 4. Why I always keep reminding about the cases is, the moment you see a problem, you should be able to think where it will correlate. Okay, now initial velocity is there. They are saying take the value of g as 10. So acceleration for all the vertical straight line motion, since we are fixing the sign convention, right, acceleration is what? G downwards. Means minus 10 meter per second square. It entire journey means what? It goes up and comes down. What is the overall displacement means? So from the position where it is dropped, it will go up and come down. But overall displacement means what? This is the initial point, this is the final point. The displacement will be what? Displacement will be how much? It will be equal to what? Minus 300. Why minus? Because it is measured downwards. Okay. Now we have to find the time. So what is the equation we have to use? Initial velocity, acceleration, displacement, time. What is the equation? S is equal to ut plus half at square, right? Means what? S is what? Minus 300 is equal to ut 13t plus half into a is what? Minus 10. 2 ones are 2 5s are. Okay, what is it? If you bring everything to the left side, what we'll have here? Minus 5t square means it will become 5t square. So 5t square, this 13t, it will become minus 13t, minus 300 is equal to 0. Like we discussed in that case 4, right? We'll get a quadratic equation. Now what is our job? We have to solve this quadratic. If we are able to solve the quadratic means we will be able to get what is the value of this time. If you solve the quadratic means we will get what is the value of the time. Okay, so how do we solve the quadratic equations? Either we should be able to factorize it or we use that discriminant formula. So either we should factorize this or we should use what? The discriminant formula, right? So here if you compare this with the standard quadratic equation, ax square plus bx plus c is equal to 0. A is what? A is 5, b is minus 13 and c is what? Minus 300. Okay, then what will be the roots? Roots of the quadratic are given by what? Minus b plus or minus root of b square minus 4ac by 2a. Okay, what is it? Minus b means what? Minus of minus 13 means plus 13 plus or minus root of b square. Minus 13, if you square it means it will become what? 169. 13 square is what? 169. Minus 4 into a is what? 5. C is what? Minus 300. Divide by 2 times of a means 2 into 5 is what? 10. So look at it. 13 plus or minus root of 169. This is what? Minus into minus will become plus. So what we have? 4 5s are 20. 20 into 300. What is it? That is 6000. 6000 divided by 10. Okay, so what we'll have is 13 plus or minus root of 6169 divided by 10. So here if you see root of 6169, this value, right, will be definitely more than 13. The value will be definitely more than 13. Means if you take the two roots, one root will be what? 13 plus root 6169 by 10. Other is what? 13 minus. If you do 13 minus, right, the time is going to come as what? Negative for us, which is not acceptable. So the acceptable value of time is what? 13 plus root 6169 by 10. This is the acceptable value for the root. Okay, so if you simplify it, right, the root of 6169. So if you simplify this, then we will be able to get the value as what? Approximately 9.15 seconds. If you simplify the expression, the value will come as what? Approximately 9.15 seconds. So when you take the square roots, right, what is the procedure? We have to choose what is the approximate perfect square, and we will see on either side of the number, like 6169 is there, right? On either side we will see one above, one below. What are the perfect square numbers? Based on that we will be able to point. Okay, so these questions, right, what happens is we will have to be resorting to some kind of these approximation methods, because if we have a number for which we are not able to get exact perfect square, right, then we have to choose what will be the approximate square root. Okay, so sometimes what happens is we might be lucky to get the number itself as a perfect square. Okay, so in those cases we will be able to get the correct answer. If not, we have to do these approximations. Okay, so what is the correct answer for this? It will be 9.15 seconds approximately. Okay, so this is how we are going to approach this type of question. Okay, and whenever we are getting quadratic, first thing is check if there is a factorization possible. Factorization is not possible means then we'll go for the discriminant approach. Okay, we'll go to the next question. A ball is thrown upwards from the top of a tower 40-meter height with a velocity 10 meter per second. This is same concept like the previous problem. Difference is what? Here we are assuming that we are throwing it from the top of a building. Same as the previous question. Okay, find the time when it strikes the ground. So same thing, right? It will go up and then it will come down. So this is the ground. So initial velocity is what? Thrown upwards. So we will take it as what? Plus 10 meter per second. What is the acceleration? Always they are saying take g is 10, means it will be what? Minus 10. Why minus 10? Because our sign convention is what? Up is positive, down is negative. Correct. And then what are the other things? We have the overall displacement. Overall displacement means what? This is the initial point, this is the final point. For the entire journey, what is the displacement going to be? Displacement is equal to what? It will be minus 40 meters. From the top it is coming down means displacement is what? Downwards. So minus 40. Okay. Then we have to find the time. Again, initial velocity is there, acceleration is there, displacement is there. We have to find the time. What is the equation? S is equal to ut plus half at square. Okay. So what is the equation? We'll have minus 40 is equal to what? 10t minus 5t square. Okay, so we can just go for some simplification. On both sides divide with 5. What we'll get? Minus 8 is equal to what? 2t minus t square. We'll bring everything to the left side. T square minus 2t minus 8 is equal to 0. Here you can see there can be some factorization. Minus 8 can be factored as what? Minus 4 into 2. Minus 8 can be factorized as what? Minus 4 into 2. So you see how we can factorize it? How we can write it as a factorization approach. So either you use the factorization approach, or if you are not comfortable means we can straight away go for the discriminant formula. That roots will be what? Minus b plus or minus root of b square minus 4ac by 2a. So here you see how we can write t square minus 4t plus 2t, okay, minus 4 into 2 is equal to what? 0. So here t will take it common, t minus 4. Here we'll take 2 common, t minus 4. So t minus 4 we take common out means it will be what? T minus 4 into t plus 2 is equal to 0. This is the factorization. So here we'll get the two values of time. T is equal to either 4 or t is equal to minus 2. Minus 2 is not acceptable to us, right? Because time we cannot accept negative, which means what? The time that we'll accept, which is the time it takes to come down, will be what? 4 seconds. So we see in the previous problem, right? We were not having these kind of perfect numbers. If they give us the numbers like this, perfect numbers, means we will be lucky enough to conclude the answer fast. If not, we will have to use the discriminant and then do some probably approximations. Okay. So this is the approach we will have to take for solving questions. So both the questions, right? The previous question and this question, both of them are based on what? The type 4. Type 4 is what? Standing on top of a tower, you throw the object upwards. Okay. Look at the next question. A stone falls from a balloon that is descending at a uniform rate of 12 meter. So the balloon is descending at what rate? 12 meter per second. Stone is falling from that balloon, means the initial velocity of that stone will be equal to what? Whatever is the velocity of the balloon, that is 12 meter per second down. As per our convention, we will take it as what? Negative. The displacement of the stone from the point of release after 10 seconds is, so from wherever it is released, right? In 10 seconds we have to find the displacement. They are saying take g is equal to what? 10 meter per second square. So acceleration we'll take it as what? Minus g, right? Because always for us downwards means what? Negative. Time they are giving for us is what? 10 seconds. In this time we have to find the displacement. Straight formula, right? S is equal to what? ut plus half at square. U is what? Minus 12 into t plus half into a is minus 10 into t square, means 10 square. So what is it? This is minus 120. 2 ones are 2 5s are 10 square is what? 100 minus 500. So what is it? Minus 620. Unit will be meter because everything is in the SI system. Now we are getting the answer as what? Minus 620. So this minus tells us what? Minus tells us that the displacement is downwards. But if you look at the options, right, they are not giving any negative answer. They are all giving positive values. Means probably what they are expecting us to tell the displacement magnitude. So we get the displacement as minus 620. Minus indicates what? This much displacement is in the downward direction as per our convention. But if you look at the displacement magnitude, right, what is the displacement magnitude? It will be how much? 620 meters. How much will be the displacement magnitude? It will be what? 620 meters. Okay, so this is another type of problem where from the top of the building we are basically throwing the object downwards. Okay, so this is about the kind of questions we can have on the vertical straight line motion, particularly the 4 cases that we discussed. What you need to do after this is make sure that you practice enough number of questions where you will be able to check how good you are able to apply these concepts, because that is the most important. While we are able to break down the vertical straight line motion into multiple scenarios to make it easy for us in approaching problems, right, we'll still have to go and work out the questions. Then only we'll be able to know. Okay, so we'll see in the next video.